Good morning, guys. Welcome back to Pre-Algebra. Today we're dividing integers, which are positive and negative signed numbers. Before we begin, I have a joke that I'd like to read to you. If you don't care a whole lot for it, I'm sure your moms and dads can appreciate it. A man runs into the vet's office carrying his dog, screaming for help. Vet rushes him back to the exam room, has him put his dog down on the table, looks over the still limp body, and after a few moments he tells the man that his dog is, regrettably, quite dead. The man, clearly agitated and not willing to accept this, demands a second opinion. The vet goes into the back room and comes out with a cat and puts the cat down next to the dog's body. The cat sniffs the body, walks from head to tail, pokes the dog, sniffs him, finally looks at the vet and meows. The vet looks at the man and says, "I'm sorry, but the cat thinks your dog is dead also." The man is still unwilling to accept the fact, so the vet brings in a black lab. The lab sniffs the body, walks from head to tail, finally looks at the vet and barks. The vet looks at the man and says, "I'm sorry, but the lab thinks your dog is dead also." Man, finally resigned to the diagnosis, thanks the vet and asks how much he owes. The vet answers, $650. $650 to tell me my dog is dead? Exclaims the man. "Well," the vet replies, "I would only have charged you $50 for my initial diagnosis. The additional $600 was for the CAT scan and the lab tests." What we have to do this morning is very, very simple. We're talking about dividing integers, which I just said are our positive and negative numbers. There are also zero. Now, integers are not fractional numbers. It's not like 1.5 or negative 3 2/3, but the rules are still going to be the same for dividing negative numbers. We simply learn these relationships that are very much related to how you multiply together positive and negative numbers, and you learn that if you have two positives multiplied together, of course your answer is positive. You have two negatives multiplied together, and we said that's sort of like a train wreck. You know, you have your two, sort of a silly little illustration, but you have your two negatives that are hitting head on and they get tangled up and they become positive. When you multiply two negatives together, you end up with a positive product. When you have oppositely signed integers that you multiply together, negative times positive, that answer is always going to be negative. Remember that inverse operations are operations that undo one another. Addition and subtraction undo one another. If I were to start with $10 in my hand, add $5, I would have $15. Subtract that same $5, and I'm back to where I began with $10 in my hand. It's the same thing with multiplication and division. They are both inverse operations for one another. If I start with a 3 and I multiply that by 2, 3 times 2 is 6. Then I would, instead of multiplying by 2, I'm going to do the inverse operation on it, perform the inverse. I'm going to divide by 2. That gets me back to my original starting number of 6. So multiplication and division are inverses. So as there's a relationship between what happens when you multiply positive and negative signed numbers together, you have the same thing with division. If you have the quotient of two positive integers, that answer is positive. You multiply two positive factors together and you have a positive product. That everybody knows. You multiply two numbers together, you get the number. You might not have thought about the fact that you were multiplying positive numbers together until you got a little bit older, but that's what you're doing. Second rule says that if we multiply, this says that the quotient of two negative integers is positive. Same thing as with multiplication. The product of two negative integers is positive. With the inverse operation, which is division, the quotient of two negative integers is also positive. Finally, what happens when we have the quotient of a positive and a negative integer? That's just the same rule as for multiplication. Your answer is going to be negative. Now I could go through and show you some patterns and say, well, see, this is what happens, and from that we sort of deduce these 3 rules here. But to go through and actually prove to you why it's true is so far beyond the scope of the course and pointless, and it would bore me to death. So just learn your 3 rules. This is what I said in our hour lecture that I missed, that once again we've got vocabulary going on. If you don't know what integers are, if you don't know what quotient is, you can't solve your problem. Remember, the quotient is the solution to a division problem, and you can indicate division in several different ways. You have the long division, dividend, divisor, and quotient. You have using this division symbol here, dividend divided by divisor gives us the quotient. We can put it in the form of a rational number where it looks like a fraction. Dividend divided by divisor is equal to quotient. So what you need to remember to do your division problems of signed numbers is that quotient, all a quotient is the solution to a division problem. You're going to look at the sign of these other numbers. If these are both positive, your answer is positive. If they're both negative, your answer is still positive. But it's when the signs of the dividend and divisor are opposite, that's when the sign of your solution, of your quotient, is going to be negative. So I'll just take a few questions right here from your text. If we have 36 divided by a negative 6. We're asking for the answer. We're asking for the quotient. Is this going to be positive or negative? You look at the sign. 36 is positive, 6 is negative. The signs are opposite, so your quotient or your solution has to be negative. It's our rule. How do we check a division problem? Multiply the quotient by the divisor. Negative 6 times the negative 6. You remember your product rules? When you multiply 2 negatives together, you get a positive. So you see that this works. Now if we have negative 162 divided by 9, it wants to find the answer, which is a quotient. We have a negative number and a positive number. What's our sign going to be? If you have a negative and a positive, it's going to be negative. Then you simply do your division, which I'm not going to take the time to do. I think it's negative 1872. Yes. You divide 162 by 9, get 18. The sign is negative because we have oppositely signed numbers here. Now what are we going to do if we have to simplify a problem that looks like this? Let's look at problem number 20 on page 130, and this is 8 times the negative 5 divided by 10. How are we going to solve this problem? You have to use order of operations to say, okay, I have multiplication and division in the same problem. I'm going to perform them in order from left to right. 8 times the negative 5, you have to remember, you multiply oppositely signed numbers. Your answer is negative. That becomes negative 40 divided by 10. When you have the problem in this form, we're looking for the solution, looking for the answer to a division problem. 40 divided by 10 is 4. If you need to show your computations, make sure that you're working over here on the right-hand side of the paper. I don't know how you want to show it. Maybe you want to do factor it like that, cancel common terms. Maybe you still like to say 40 divided by 10 is 4. 40. And I would expect at this point many of you to know that 40 divided by 10 is just simply 4 on its own. So we've done the calculation, come up with 4. Now we have to know, what do we do with the sign? We have a negative divided by a positive. When you have opposite signs, your quotient is always negative. So the answer to this problem is a negative 4. Now let's go ahead and look at number 26. We have negative 3 minus 7 divided by negative 5. You have to simplify this as well. Well, here we are subtracting sign numbers. We know that subtraction is the same as adding the opposite. If you can already look at this and you've learned that negative 3 minus 7 is a negative 10, that's fine. If you can't, remember that subtraction is the same as adding the opposite. Here we have subtracted 7, so we want to add the opposite. We want to add the opposite of 7, which is a negative 7. We now have negative 3 plus a negative 7, so the signs are the same. When you add together two numbers with the same sign, you keep their sign. So you have negative 10 divided by a negative 5. The answer to a division problem where the signs are the same is always positive. The answer of a division problem is a quotient. Negative 10 divided by negative 5 is a positive 2 because the signs are the same. That's all you do with these problems. You'll also have maybe a couple where you have to substitute in a value and then find your quotient. This is nothing different than what we've been doing for a long time now. Number 30 says negative 54 plus d plus a negative 3 for d equals 9. Now if you had just walked into this and maybe your first day in class or last year and you saw that and you thought, good grief, I have no idea what I'm supposed to do with that. Well, now you know that when you have a variable in an expression, you have a value for that variable. Instead of using the d, we're going to use a 9. So this now becomes, I think this was number 30. This now becomes negative 54 plus 9 plus a negative 3. We have parentheses that says we have to perform the mathematical operation inside here first. What are we doing? We're adding differently signed numbers. Positive 9, negative 3. How do you add those? We subtract their absolute values. 9 minus 3 is 6. And you use the sign of the larger number. I'm wondering where my... Okay. My bifocals aren't working here. Sorry about that, y'all. It's actually a division problem right there. Everything I've done so far is just fine. We've substituted in the 9 for the d. So I have negative 54 divided by a positive 6 when we added our oppositely signed integers. We have a negative divided by a positive. That quotient, or that answer, is always negative. We have a negative 9. 6 times a negative 9 gives us a negative 54. That's all that there is on these problems. So y'all work on those and you should not have any difficulty with them.